So Josh, I'm going to turn it over to you.
Great. Well, thanks everybody for joining. Looking forward to demoing what we've been working on for a very long time. I'm super happy with the progress we've made on it, and even more excited about where I think we're going to go from here. So yeah, Tim mentioned there's a lot of it's a diverse background to the audience today. So I'm not going to make any assumptions on how much people already know about Afterglow. So I'm kind of going to start with the brief history. Let me know at any point if my internet connection goes out or I'm hard to hear. But this all began, I would say, probably Dan can correct me, but it is at least 9 years ago. We had Skynet, the robotic telescope network, up and running. We had students of all ages in partnership with Yerkes and other places using the telescopes, acquiring data. Even in our labs, they were using our telescopes through our web interface and acquiring data. But we quickly realized that the weakness was in when we asked them to analyze that data. So we had lots of problems that we were encountering from most of the software that was available was not free. We couldn't obviously charge all of the students to buy their own license for software. In addition to that, astronomical data can be very large. There's some big file sizes, and a lot of projects require taking a lot of data. And so imagine even 8 or 9 years ago asking students to download sometimes a gigabyte of data. It can be hundreds of megabytes, sometimes gigabytes of data just to do the processing. And so that, alongside the permissions issues of installing software, led us down the road of web applications. And so this began as Afterglow. The original version was written in Flash many years ago as a proof of concept. As a web application, it's running right in the browser. Which means that students don't have to install any software. And also, since it's a web application, it's communicating to our server where all of the data exists and already has been stored at Skynet, which means that instead of requiring the user to download all of that data to do the processing, they can simply send requests to the server, tell the server what they want done with the data, and the server can take it from there and then just send them what's the data results. So that drastically decreases the bandwidth requirement there. So over the years that evolved, and as most people here probably know, Flash was an amazing thing and served its purpose during its time, but now with the evolution of web technologies, it's no longer needed and is obsolete. So iData, fast forward to iData, and part of the project here was to completely rewrite Afterglow to take advantage of these new web technologies. And we decided to go with a framework called Angular. It was created by a team at Google, and it's essentially pure JavaScript and HTML. So no more Flash, no more requirements. It is just pure JavaScript and HTML that's running in the browser. So everything you see, there's no Java, there's no JavaScript, there's no embedded anything. It is just JavaScript or no ActionScript, sorry, and it is just JavaScript and HTML running. So there was focus in iData for accessibility, so I will spend a lot of time talking about accessibility and sonification, since that was a major component to iData. But just to start, we realized early on there are kind of two parts here. There's the client side. There's the stuff that's running in your browser, which I have displayed right now, the Afterglow Access client side application. But the second component, which I do want to mention because it does play a role in accessibility, is what's running on the server. And so we designated that, we gave it a name called Afterglow Core. Afterglow Core is its own thing. It was not written specifically for Afterglow Access. It is a general purpose astronomical image data processing pipeline. And it exposes an API, what we call an API, a RESTful API, which is about as accessible as it gets, because any student, any client can use an API token to write their own script in whatever programming language they want and interact directly with our server to create these processing jobs, to import their data, to do all of the analysis, and not ever have to even click a mouse button on the screen within Afterglow Access. So I like starting with the core, because that was in itself a major undertaking that Vladimir, another software engineer here at Skynet, took the lead on. and it's written in Python and is all open source and is obviously a key component to the project. But with that said, iData was focused on the front end, the client side. So this demo, I'll go ahead and get started here on Afterglow Access. So accessibility, before I even open an image here, we did spend time through a user-centered design process discussing themes and font sizes. And so that is available through the profile, where some people through the user-centered design process requested the yellow on black theme that is common for some low vision. And as well as providing the standard kind of dark as well as a light template, a light theme. So those are available, as well as changing font size and font weight. The quick start guide includes keyboard shortcuts. I will note that the keyboard shortcuts, we are, after this last major development process, we're still working through the best way to re-implement those. Most of them work, but some of them you might find are not functioning as well as they should. And obviously that will be a part of the next week or so before the big 1.0 release. But additional information about accessibility can be found there. As a part of this last 3 months of development effort, we've moved towards kind of more of a desktop application feel where you open files, you can manipulate those files, make changes, and with the most recent changes, you can save the new data that you've created to your own workspace. So we have a file browser that we've built in as a part of the application, which allows you to explore what data is available on the core, on the server side. And for this demo, a lot of times I'll stick in the sample data, but it's plugin based in the core. So you can write your own plugin when you install your instance of Afterglow. In our case, we wrote a plugin that allows users to access their data directly from Skynet. So as their data is being taken by our network, it appears immediately in the Skynet directory here. But like I said, for this demo, I'm going to hop into sample here and jump down to a workshop demo, and let's just open an image of Saturn. So the look and feels very pan zoom like, kind of like Google Maps, where you click and drag. And I always have to emphasize that because you're seeing a screen broadcast, things might look jumpy, things might not look smooth and nice when I zoom or pan, but I assure you, if you're using the software, it is very responsive and super performant. So you're able to click and drag to pan around the image. Scroll wheel works just like it would in Google Maps for zooming in and out. Zooming all the way into the individual pixel versus viewing the whole image. We have the stat. Yeah.
Question for you.
Yeah.
As far as the question from the crowd here is, does the data have to be be a FITS file? Yeah,
it's a good question. So we do support uploading and opening many different image file types, including FITS and JPEG. Behind the scenes on the server, we are doing a conversion to standardize everything into FITS. So we're not maintaining that raw data format, but we do allow behind the scenes a conversion to take place where everything is stored as FITS on the server. So we do support additional types. Now, in regards to the type of FITS files, with a lot of the recent development effort, we kept in mind that a FITS file can have multiple header data units, multiple parts to the file, and each part doesn't have to have image data. It could be tabular data as well. So Afterglow Access is aware of that concept. The architecture was designed to support that. We do not currently have a viewer for tabular data, but I'll actually show later in the demo that if you opened a FITS file that had tabular data in it, you'll see that there's tabular data there, and then at some point in the future, when we're able to develop that viewer, you'll be able to see the tabular data and interact with it just like you do with the image data.
Okay, and so is there any special prep? I mean, if somebody's going to upload a file, a FITS file, it pretty much uses the standard FITS, accesses a standard FITS format, or is there header prep that people are going to need to do?
So there are no required headers other than those that are required by the FIT standard. So you don't have to do any prep work. We are still working on defining what standards we want to implement for which keywords in a header you might add if you want Afterglow access to behave a certain way or the core to behave a certain way. But we have not done that yet fully. So yeah, nothing's required. You're able to just upload whatever file you have, but if you have additional keywords and the right keywords in your header, it'll make your life easier in Afterglow because new features will appear. You'll end up with WCS coordinates, or you'll get scale information, pixel scale information that can be beneficial when using certain tools. So we've opened this image of Saturn. I'm demoing zooming in, moving the mouse around, and you can tell that there's no RE in deck because this is a planetary image and we don't have what we call world coordinate system registered. So we don't know exactly what part of the sky we were looking in. But you still can move your mouse over each individual pixel and get sub-pixel accuracy of where your mouse is, as well as what that pixel value is in the raw image data. As some of you know, astronomical image cameras, as well as a lot of nice cameras, digital cameras, the raw data, the pixel data is actually 16-bit integers. And so the pixel values can range from 0 up to 65,000 or so. And so when you're trying to display that on a screen, the common problem that you run into is screens don't display that range of data. They stick to a red, a green, and a blue value that are each 8-bit. So 0 to 55. So that's your range. So a mapping has to take place, and that's what you typically hear of brightness and contrast settings, normalization. So that's the default tool that appears. You get a histogram view of this image that you've opened, as well as some of the default settings for that brightness and contrast normalization, how we map from the 16-bit integer to the red, green, and blue value. We've done a lot of work on trying to get some good presets. We don't want users every time to open an image and it not look great and then have to make changes. A planet is an example of where there are kind of two different brightness and contrast settings that are super useful. One is where you want to see the faint object. So in the default here, we've adjusted the brightness and contrast so that you get to see all of the faint moons around Saturn, but you don't really get to see a lot of the detail of Saturn because it's washed out. So that would be where the bright target preset comes in. So we can just click bright target, and now we've adjusted the brightness and contrast to see Saturn. And the moons, of course, are now back below the background level and we can't see them. You can use the number inputs here and use the scroll bar here to make adjustments that are a lot finer grained to allow you to kind of find a compromise between the two if none of the three presets are quite what you're looking for. In this case, I've washed out most of Saturn, but at least now I can see some of the moons. As a part of that mapping, that normalization process, everything you've seen so far, I'm mapping the 16-bit integer to a grayscale value. So there's no color. I'm just setting red, green, and blue to the exact same value, and you end up with a grayscale image, but that's not required. This is where you typically hear color palette. That's a phrase that's used where you might not want to map always to a grayscale value. You might want to map certain 16-bit values into red colors, certain other values into blue and green, and combination of those. So we do support color maps. Here's an example. If you switch to a rainbow color map, then you can see things get a little more exciting with lots of fun colors. You could do a range of blue colors, so not pure blue, but various shades of blue, various shades of red, which we call the cool and the heat color map. And in addition, I want to emphasize, because we'll come back to this, you do have the ability to say that I would like this displayed as a purely red color map. So this is just pure red. There are no green or blue components. Same for the other color maps as well, for the blue and the green. Stretch mode, I won't go into the detail there, but we did add support for some and can easily add more should we find them to be beneficial, which is just a different mapping when you're doing that normalization.
Josh, you have a question here.
Yeah.
From the Worldwide Telescope was developed originally by Curtis Wong of Microsoft Research, use with astronomy data sets like SDSS. It is now an open source project. How does this compare with this system? Do you have thoughts on that?
So I don't have a lot of experience with it. Maybe others in here who have and have also had experience with Afterglow could speak to that. But yeah, if anybody.
Oh, but Afterglow is, can you talk briefly just about the open source nature of it, or the, that it is?
Yeah, so Afterglow is open source. Our code is fully available. Thus far, it's all been on our own repository that is available through code.skynet.unc.edu. I can post a link. We may be moving that to GitHub when we want to start building up more of the user community support. Right now, there's been a lot of focus on us being able to rapidly implement and deploy features. The time scale on that is not, let's wait till the next release in a month or two. It's literally, hey, we want this feature, let's add it and release it tonight. And so that will change once once we build up the user community that can help with the development process. But yes, the code is there, it's available. Documentation is a work in progress, but yeah, we're hoping that this becomes a project that many people are contributing to.
Okay, thanks.
Yeah.
Louisa points out that the Worldwide Telescope does not do photometry, and we do.
Okay. Yeah. So as I go through the demo, that people that are familiar with Worldwide Telescope, feel free to put in the chat, like if there's things that they've seen in Worldwide Telescope that they feel like would be a good thing in Afterglow, great. Or if you see things that we have that aren't there, that that would be good to know as well. In regards to the display settings, obviously there's inversion. I'm going to switch back to the grayscale. You can invert images. Sometimes that's easier for accessibility purposes, as well as for data analysis purposes to invert the color map that's being used, as well as flip the standard flipping and mirroring of what's being displayed, as well as rotation. So that covers display settings. I don't know if there was anything else there, if there were any other questions. I don't see them in the chat.
Josh,
yeah,
are you going to get to, or as far as how do I upload an image from?
Yeah, I'll get to that. I'll make that, that's a little towards the end. I will absolutely, if I don't, then make sure to remind me. Yeah. So we have, on the right side of Afterglow Access, things are kind of laid out. So on the left side, you have access to all the files that you've imported or opened into your workspace. On the right side is where all the tools are. And so by default, it's the eye icon, which is the display settings tool, but I've now switched down to the info icon, which is viewing the header information. So the metadata that is associated with your current file that you're viewing. And we go ahead and try to, sometimes header information in FITS files can be a bit overwhelming. There's a lot of data there that's being stored. So by default, we extract out what we think is useful. This goes to what Tim was mentioning earlier. If your FITS image has no header information other than what's required, you're not going to see anything here. We won't know what filter it was taken in. We won't know what the exposure length is, and we won't even know when it was taken. So that will limit what you could do in terms of data analysis or how useful the data might be. So this would be a good place to go to see whether you've added the right FITS headers or if maybe you're missing some. But if you want to view the raw header information, you can toggle that as well. And this is coming straight out of the FITS file. Along with the comments, the keyword and values. So not a lot to talk about. Switching between system time, that's useful, we found, for labs and for when students are using Afterglow. Sometimes it's confusing to be in UT time versus their local time. So we do allow quick switching between that. Markers. So a lot of times, especially for education and for research, you're kind of making a finder chart, or you're trying to identify different sources so that you could then potentially, as a student, upload that image as a part of your project that you're working on. We have some, it's right now very rudimentary marking abilities, but the infrastructure's there to go a lot farther here. Right now it's click and you get a circle. You can click on the circle, and currently you can customize it by, let's say you wanted to name whatever the marker is. If we, for example, knew that this moon was Mimas, then we could put that there. You can change the radius, so you can make changes and in real time tweak how the marker is being displayed, as well as where the orientation of your labels, so that you can prevent things from overlapping. But like I said, in the future, the infrastructure is there to add in the rectangular markers, all sorts of things that you see in standard finding charts when you've discovered something and want to send that to others so that they know where it is. That's where this will eventually be implemented. Let's see if I see any questions about this. I don't think so. So yeah, fairly straightforward. We do offer centroiding. So you'll see centroiding throughout Afterglow. So this centroiding is done client side. So I coded this into the JavaScript application, which makes it very responsive and means that you can click. What centroiding is where if you click on a point source or a planet, if you have planet centroiding on, let's say you didn't quite click in the center, you don't have to worry about where you clicked, because as long as centroiding's on, it will shift your click over to what it has determined through an algorithm to be kind of the center pixel, sub-pixel location of what you've clicked. So it is somewhat useful in markers, but you can imagine it being a lot more useful in some of these other tools like photometry and plotting. All right, so moving on to the plotter. So we call it the plotter because there's a lot in the future that we envision being done here. Currently, it can do two really useful things, which one of them is cross-section analysis. So imagine clicking and drawing a line right through Saturn. Let me switch our view back so that we're looking at Saturn, and let me take off the inversion, and we'll go back to the plotter. So by drawing a line right through Saturn here, we can see the rings, and you can analyze and look at the cross section of the raw pixel data that you've acquired of Saturn. Another useful thing that a lot of people use the plotter for are measuring angular separations and pixel separations between sources. So if we switch back to the default here and start looking at some of the point sources, imagine wanting to determine the mass of Saturn as a project. As long as you know I'm not an astronomer, it's been a long time since I've done it, so Dan can correct me, but I believe the way this works is you can basically build up a spreadsheet where you've measured the position of each of the moons over a period of time. And as long as you build that spreadsheet up and have that data, and you're given or you determine through parallax how far away Saturn is that correct? That's all you need to, okay, that's all you need to come up with the mass. So imagine going to the plotter and saying, okay, I would like to start building up that information, that spreadsheet. We can turn centroiding on because we're about to click on a moon. And then we're about to click on a planet. Typical PSF centroiding doesn't work really well on planets because they look different. They're a disk. They're not an individual point of light. So you can come over and switch on planet centroiding and click on the planet, and that does a better job getting you centrally located within Saturn's disk. And then here's the data. So you have a start pixel, you have an end pixel, and we go ahead and calculate what that length, what the separation is between those two clicks. Because this image does have pixel scale information, we can convert that into an angular separation between your two clicks, like the angular separation on the sky, which is super useful for doing conversions. And if this image had been registered with WCS, which we'll talk about later, it would also give you that coordinate separation in sky coordinates. So how far in right ascension and declination, and where you pointed to the north, what's the position angle of that line you've drawn. So a lot of information will appear, extra information will appear if the image has that WCS. Anything else in this. So yeah, as I was mentioning, you could repeat this process for the moons, open up other images, build up that spreadsheet, and come up with your estimate for what the mass of Saturn is using a tool like this. So the next tool it came very much out of iData. We weren't necessarily directly requested to do this, but during the workshops and during our involvement, we were inspired and decided, hey, we felt like we could make a really neat and useful tool for blind and visually impaired students. So we came up with our own sonification algorithm, and I typically, let me close out of this image here, and I'm going to kind of jump over quickly into sample and go into a sonification directory here and just open up a different set of data. Because with all sonification algorithms, you have to take a minute to go through kind of a training process, right? And it doesn't take long, but it's required for all sonification algorithms to help the user develop a way of mapping the spatial data that's being displayed on the screen into the sound that they're hearing and understand how that mapping is taking place. So I always like to open up the sample data because I start by saying, here's how our algorithm works, the rudimentary. You ready? It's put piano keys across the bottom of the image, right? So place an entire piano keys across the bottom edge of the image. And now slowly start to slide the piano upward towards the top of the image. Anytime a star or some source appears beneath a piano key, tap the piano key. If it's a really bright source, tap the piano key really hard. If it's a really faint source, just kind of tap the piano key really lightly. That's basically what the algorithm's doing. It's a lot more advanced than that. There's a lot more to it behind the scenes. We're doing it on a per pixel basis, so not looking for stars. We also do things with the algorithm where we will play sounds. Based on what I described, the left side of the piano is the lower frequencies, right? So if you encounter a source towards the bottom of the image, right, as you start sliding your piano up, if it's on the left side of the image, you would be tapping a piano key on the left side, which would be a low frequency, a low tone. If it was a source on the right side, it would be higher frequency, a higher tone. So we also try to do differential amplitude as well as phasing to enhance the effect that a lower frequency source came from the left side of the image versus a higher frequency coming from the right. But with that, this is an image that I have displayed as a single star in the center. You'll hear an index sound at the beginning of the sonification. I wonder if I have to do anything to share. No, okay. So did that
Josh,
come across or not?
I think it only came into your headphones.
Yeah,
That's
you
what I was
need to
gonna
share
ask.
the sound, not just share your
Got it.
screen. There's a separate button to share sound.
So let me go into more here and share sound. Got it? Okay. And I'm going to try again. So because an empty image would have no sound, it's useful for accessibility purposes and blind and visually impaired students to play an indexing sound at the beginning and an indexing sound at the end of the recording so you know when it's starting and stopping. But beyond that, let's see if the sound comes through this time. So if it came through that time, you would have heard an index sound at the beginning of the recording. Halfway through the recording, I have a single generated star that's right in the middle of the image. So halfway through the recording, we've reached the star. We hit the piano key right in the middle of the keyboard, which is kind of a mid-range frequency, which you hear, and then it's quiet and silent basically until you reach the end and you hear the last indexing sound. So quickly, as part of the training, you could take, instead of one star in the center, put 3 stars in a vertical line running right through the middle of the image. You can start to build up an idea of what this would sound like. Same tone, equally spaced out throughout the recording. What if you rotated that so it's now at a diagonal? So your first star is in the lower left corner and your last star is in the upper right corner, 3 stars. So low frequency, central frequency, high frequency. And we typically go through the rest of these, but I'm going to jump to the fun stuff like a globular cluster. So now let's move to real data, not just the training data. And what would a globular cluster sound like? So sounds neat. We definitely we haven't done any formalized tests, but just in some of the workshops, we had fun playing some, and blind and visually impaired students were able to identify galaxies versus globular clusters versus other types of objects like planets. So that was super exciting, and we definitely see that there's a lot more to be done, and we're looking forward to development there. Galaxies, we do add one extra layer to the audio, which is extended sources. We use white noise. And so you might hear a little fuzzy white noise when we go over the galaxy here. It's just kind of a hissing in the background to convey that tone that was at the same time as the white noise is more of an extended source, not just a point source like a star. Satellite, what would that sound like? I think everyone can probably imagine that it would be super easy to recognize a satellite running through your image. And I'm gonna skip over the others because you can feel free to play with it when you connect and log in and experiment on your own, but you can see that this can be extremely useful for blind and visually impaired. Even more useful when you keep in mind that we went the extra step of saying, hey, how would you navigate the image using the sonification, and provided the keyboard shortcuts for that. So here's an image where even if you didn't look at it, you should be able to fairly easily tell that there is a single source of interest, and it occurs towards the end of the recording, and it was sort of central frequency. So if you know it was towards the end of the recording, you can press 3, and if you know if it was sort of central frequency, you can press 5. I'm using the number pad, which makes more sense. And I've just zoomed in on the source. I can press the dot period, which is right next here, so I'm not having to move my hand anywhere. And it plays it again, but you've zoomed in on it. So you're getting a higher resolution sonification. You know that that was, once again, towards the center of your recording and was also fairly central in frequency. So you can repeat the process, and just with some clicks of the number pad, you can hear a moon of Saturn followed by the elongation of Saturn, which that's pretty cool. So I'm going to stop with the sonification. As fun as it is, I could probably spend the entire hour talking about sonification, but you can imagine that this is just the beginning here. I feel like there's a lot of really, really cool stuff that can be done with sonifying astronomical image data. Photometry. Let me jump over to photometry. So I always like to use my tried and true data set that I'm sure a lot of you have seen, but it's just what I love using because it demos so much in one go, which is a data set of Cleopatra. It's an asteroid that is very elongated. I'm gonna come over here and import a bunch of images. So remember importing, opening, I didn't have to transfer I think that was probably 300 megs. So I did not just have to transfer 300 megs to my computer. I just told the server, hey, go ahead and pull this data into a place that you can work on it, and then let me know when I'm ready to start viewing what I want to view and start processing what I want to process. And so I actually need to clear some sources here because I forgot to do that. But you can, now that that data has been loaded and opened, the first step is finding where is the asteroid. There are several different ways of doing that. I will demo one of those ways, but the easiest that I have found that's not accessible, we're working on a more accessible way of doing this, but the easiest way that I have found is to use our import from the Digital Sky Survey. Currently, the DSS is the only place that we allow importing from, but the core actually is, we're working on the component that will allow access to a lot of different catalogs through third-party services. And so if we just click on Import DSS here, this will show a feature that I haven't displayed yet. The viewer is a tab-based viewer. So just like Chrome, just like your browser that has many different tabs that you can split the screen, that's what I've added in here to Afterglow Access, which means that we can split this to the right. Now we've loaded a catalog image of the same field that was taken at some other time, most likely a time when the asteroid was not in the field, and put it right alongside our image. And because both of these images have been synced up with the sky through what we call world coordinate system, we know exactly which part of the sky, the orientation, the scale of the sky of the image, and can therefore, since we have that information for both of these images, we can link them. And we can link them in such a way that as you move one, it moves the other. And is displaying the exact same region of the sky in both of the viewers. So as you zoom in, you can very quickly see that this star that's in our image matches this star that was in the catalog image. What we are looking for is some source that is in our image, but is not in the catalog image. And you can see that this bright object here is not found in the catalog. And so this is Clio. This is our asteroid that we're looking for. So that's one quick way of finding the asteroid. More accessible way would be to maybe align all of the images and stack all of the images. And then you would see a streak, a star trail that looks very much like a satellite trail running through the image. Imagine using sonification then, right? To sonify this image that you've generated in an accessible way, to then navigate and zoom in and locate where that asteroid is in each of the images. That's one of the possible pathways towards making this process accessible. I think Kate sent something. I'll let Tim parse that and let me know if it's pertaining to this. But back to photometry. So we've now identified where the asteroid is. Let's say our task is to measure how bright this asteroid is, not just in this image, but in the 100 other images that I imported. The best way to do that, or one way that we allow for that to be done in this photometry tool, is through building up your own source catalog. So you're essentially telling Afterglow Access which sources am I interested in photometering. And so you do that by simply clicking on the sources. So I've selected our reference star as well as Clio. Now, these two sources have been added, that we have their right ascension and their declination, which means that in every other image, we could go to that same part of the sky and we could photometer that same location and get how bright the source is at that location throughout all of our data without having to open any more of our images, which is super beneficial. However, the asteroid's not staying in the same place. So imagine if we did that, we would get the asteroid in the first few images, but then at some point the asteroid would have moved outside of where we said we were photometering. As you can see here by image 6, it's now not even within the centroiding radius, so we would get no data there. So what we did is we added an extra feature in photometry where you can simply jump to some of your images, just kind of flip through a random set of images and continue clicking on the asteroid. And you can see the direction that it's moving here. And so once you've clicked on it a few times, however many times you want, you can actually tell Afterglow that these are not all different sources. This is the same source that happens to be moving through the image. So by selecting them, we can come over and merge that source. Now Afterglow has enough information to extrapolate and interpolate throughout the rest of your data set. So even images that you have not even opened yet, we can nail exactly where the asteroid will be or was. And now Afterglow has enough information to tell the core where it should photometer, which means without opening any more data, any more images, transferring, no more bandwidth requirements, we simply send the request to the core to do this photometry job on all of our images. And out comes a spreadsheet, a CSV file, which you can open up. And I have already opened it and made the chart. It's super easy to make the chart, but I figured I'd save a minute of time here by having it pre-made where you get all of the information from the photometry. We're subtracting, in this case, our reference star magnitude from our asteroid magnitude. And And check out Clio. I mean, Clio's super elongated. It looks like a dog bone. So as it rotates and tumbles, when its long broadside is facing the Earth, it's super bright, and then it spins around, so its narrow side is facing the Earth. It has less cross-sectional area, so it's a lot fainter. So easily can see that right here in this beautiful light curve generated through Afterglow Access. We do have a lot of photometry settings. The defaults are typically sufficient so that students don't need to go into the details, but a lot of what the core uses is AstroPi. And so a lot of the functionality that and the options that you see in AstroPi will be eventually exposed or already are exposed here in our settings. The last thing I'll mention in photometry is thus far I've shown clicking on sources to photometer them and to add them to your catalog. But we do also plan on adding other ways of adding sources. So we already have source extraction. So you're able to extract the sources automatically using your own threshold values. But you could envision another option being upload your CSV or a text file, which has the coordinates of all of your objects that you're interested in photometering. That I think will be another very useful feature that we plan to add in the future. Anything else on photometry before I breeze through the last few so that I have time to talk about color images, which I know a lot of people that have been with Afterglow from the beginning are very excited about. All right, I don't see any. So briefly, I'm not going to actually demo it, but rooted like lower level pixel math sort of stuff, like subtract this image from this image. It's great for education, also useful at times in research. That's there, as well as advanced stuff where you can use operation strings to do pixel manipulation, accessing some of the raw functionality or the core functionality inside AstroPi, and some of the libraries that are built in, median filters, the rest of that currently is accessible through operation strings. You just have to know what to type, what functions to access, and which images you want to apply that to. Wcs calibration, I mentioned that earlier. Let's say your image hasn't been synced up with its location in the sky. We haven't made that connection. Using astrometry.net, our local instance of astrometry.net's algorithms, we're able to extract the stars from your image and look at existing catalogs and make that match, and then add that information to your file so that you can take advantage of a lot of this other functionality in Afterglow that does rely on that. Aligning and stacking, I'm going to skip that for right now. It's fairly straightforward. You select the images that you want to align, and currently we support aligning images through that WCS. But it's certainly in the plans to add support for other alignment methods, such as single star, multi-star clicking, correlation. Those sorts of things are certainly feasible to add. And those two tools work very similarly. Select what you want to align or stack, and then press submit, and it appears as a new file. So I'm going to stop there with the tools. I'm going to clear out my open images since there are a bunch of them here. So it's going to go through and close out all of those files. To address what Tim was asking, up until a few months ago, all of Afterglow was read-only. It was, you can import your data that's in sample or from Skynet or from one of the plugins. You can manipulate it and make changes to the data, but you couldn't save those changes anywhere. You couldn't even pull the changes out and download them, and you certainly couldn't upload your own data into the system. But that now has changed. We have a new plugin, which is the Workspace, or a writable plugin, which we call the Workspace, that gives users a quota. They can then upload their own data. And so I'm going to click upload here. And I downloaded a few images from Hubble Heritage, which is of the Eagle Nebula in various narrowband filters. And these are big files. Currently our upload, we don't do multi-part uploads, so I can't give an exact progress, but that's something we're working on as well. So it gives you that it's working on it, and then once it's done, it will tell you that the upload has been completed. So for a long time, people wanted color image work, and and to be able to generate color images in Afterglow. And there's a lot to that. And I was worried that doing that all on the client side was not feasible. But within Angular and within this rewrite, it was possible. And so we've worked on that in the past few months. Let me open up these 3 images I just uploaded. They're now in my workspace. So you would open them just like you would any other files. Notice that each of these files, actually, this is an example where they have 2 different HDUs. So they're a FITS file that has an image component and a table component. So this goes to that, whoever asked that question early on, this is what it would look like. You can see the table, but if you tried to click the table, it opens a new tab and says, not yet. We're working on it. It shouldn't be too difficult to add, but all the rest of the architecture is there to support tables. So we're looking forward to being able to at least display those. New functionality here is you can see that each of the HDUs have been grouped under the file name, the parent file. What we would like to do is generate a color image. So we need the 3 image HDUs to be grouped together in a single file. So what I'm going to do is I'm just going to select all here, and there's a dot drop down that says, hey, I would like to split these files. So first I'm going to split them. Instead of 3 files that each have 2 HDUs, now I've got the raw, all 6 of them separate. Now I'm going to actually select just the image HDUs. So here's the 3 image HDUs, and I'm going to go back to the same option, and I'm going to group these together because I would like to make a color image using these. So I've grouped them together. You can still view them just like we were viewing other files. So here's clicking on the individual component HDUs. You can see the 3. But the new feature here is there's a top level item. The top level, which it's extracted out, is Eagle. We can click on Eagle. This is the composite. So behind the scenes, client side, we are taking all of the raw pixel values for each of the components. We're blending those components together based on your settings, and we're generating a composite. Not a very impressive color image, I would say, because there's no color. So what you can do is what I mentioned very early on in the demo. What we would like to do is go into the 502 component here, and instead of using a gray color map, why not map these raw pixel values into red? And for the 656, why don't we map that into green? And let's map the 673 into blue. Now what happens if we go back to the composite? You clearly get not what I was expecting because I've chosen the wrong colors. So let me change. They've imported in a different order than I'm used to. Let's see here. So let's make, I think that this one should be blue. There's a Hubble palette that produces what the standard picture is. Let's make this one green. And let's see if we make this one red. Do we end up with what we expect? There it is. All right, so you get the right color mappings in for each of your narrowband filters, and there it is, the classic picture that most people here have probably seen. And the neat thing about this is, unlike using Photoshop with FITS Liberator or some other tool where you have to, at the very beginning, the first step is to convert that raw 16-bit integer data into your displayable 8-bit data, you're able to preserve that raw data and have the composite generated on the fly as you make changes. So there's a new list here for layers, which is over on the display settings, allowing quicker access to switching between them. So as you make changes, let's say you want to bring a little more red out. I'm going to zoom into a region here. I've selected the red layer, which is the 673, and I'm going to go to the saturation levels. And I'm going to start modifying the saturation levels. And you can see in real time that red component is coming out, making the image a lot warmer. Same for the blue component. You want to bring some more blue out in real time, you can make the changes and see that effect right in the composite. So color image support, it's rudimentary, it's fairly simple, but it is something we've wanted for a very long time, and was a pretty big undertaking to get implemented. Beyond that, I'm going to pause because I know that we wanted a Q&A time, and I know I've left only 5 minutes, but If there's anything else that people really wanted to see, I can jump to that pretty quickly. Otherwise, happy to answer any of the questions that Tim has compiled.
Thanks, Josh. So this is awesome. It's great. This is obviously a very powerful tool. I just do want to let folks know that currently the team does have a follow-up proposal into NSF to continue the development of the software in making a lot of these other features accessible for the BVI community. We're waiting to hear something on that. We should be hearing something, I think, within the next month as to whether or not it's a positive outcome, or at least heading in that direction, or it's a negative outcome for the proposal that's in. In addition to that, we are very shortly going to be translating this into Spanish. So there will be a Spanish version of the software. And that I'm thinking time-wise, we plan to go ahead and make this available on the AUI server just to the general public, probably the next week, the first week of March sometime. And then we will, I'm gonna guess that probably we're a few months away from being able to have a Spanish version, or at least 2 to 3 months away, so that you'll be able to basically the English, what you're reading here in English is going to be in Spanish, and we did that intentionally for dissemination in Chile as far as well as Latin America. So those are a few things that are on the horizon with this. And again, I will keep everybody posted as to when we have this ready to go off of the AUI server, and you can go in and play around with this a bit. So any Josh, any questions? Feel free to either ask them verbally or place them in the chat window. Anything more for Josh or about the project?
There's a question in the chat about saving as PNG or JPEG.
Yeah, so currently you can pull your file back out by either downloading the raw file, which is by selecting the file in your list, and then one of the options is download the selected file. That will, I think, always return back a FITS file because, like I said, we're standardizing everything as a FITS file. But in terms of quickly extracting a PNG that's kind of a screenshot for purposes of uploading for student or educational purposes, right now the best way is through the camera icon that's in the toolbar. The camera icon will quickly take a screenshot of that, whatever's being displayed, and provide that to you. So we definitely need one extra, that's 2 different types of exporting tools. We likely will need a third, which is I want this, what's being displayed, but at full resolution as a PNG or a TIFF or some other thing that is not currently available.
There's a question in sonification. Can you vary left to right in addition to low to high frequency? That is, if something is on the left, you hear it more on the left side speaker.
Yes, we do that now. So part of our algorithm, we do artificially increase the amplitude in the stereo tracks based on whether it is low frequency or high frequency. So high frequency is predominantly higher, is predominantly in your right stereo track versus the lower frequencies in your left. And while it wasn't super beneficial when I was testing it, that doesn't mean a lot, but the phase shifting was not, I didn't find that to be very convincing, but we do also shift the phases a little bit to try to tease your brain into thinking it came from over there or it came from over there based on the timing. So I think the amplitude difference was a much more effective way of conveying that.
Question, Josh, from Kathy. I'm assuming you can still do the tool panel by itself? et cetera, for accessibility?
Yes, you can. And those were some of the keyboard shortcuts that I found out that I had them working last week and found out that they are not currently working in this demo, which is why I strategically did not demo that, but we'll have it fixed in the next day or two. The idea is the keyboard shortcuts make it so that you can expand the file browser to cover the entire page. And then quickly switch to just expanding and viewing the central viewer or the tool panel. It allows BVI students or low vision students to, my understanding is it helps them figure out where they are on the page and navigate the page a lot quicker. So yes, that functionality is certainly still there, but the keyboard shortcuts are not working right this moment.
Question from Sarah. I've used Afterglow for Skynet programs with 6 to 12 graders. Will Afterglow Access be replacing Afterglow and Astro image processor that are linked in the SJS explorations?
Let Kate speak.
That is that's a very good question. And Tyler might have a better response than I do, because all I'm going to say is that we are discussing what this looks like for the original SJS portal, and I don't know if Tyler is still on. Probably not. He might have left. But it's under discussion right now, Sarah.
All right, I don't see any more questions, but feel free to either type or throw out anything else. Otherwise, yeah, looking forward to the future of Afterglow. It's come a long way from those that have been with it from the beginning as a proof of concept in Flash that we kind of put together to this as a lot of progress. I'm very excited about where we're going to go from here. Okay.
Well, thanks, Josh and Dan, for all your work at UNC and with Skynet. This is, it's just an awesome tool. It's really great to kind of see it now available in the real world after many years of conversations and discussions. So thanks again. And we don't have any more questions, but I will let everybody know once this is available via the AUI server at some point next week, and you should be able to get in and play around with it.
Well, yeah, thank you, everybody.
All right, thanks a lot.
Thanks, Josh. Good to see you, Dan. Tim, take care.
You too.
Good job, everybody.